Here some of the bolt, that is different types of bolt is there. That is common type of bolt are, first one is hex bolt, that is hex cap screw. When we are seeing this diagram, we know that the head of this bolt shape is hexagonal. That is most commonly used bolt has a hexagonal head used in construction machineries and automotive. Then second type is carriage bolt. The carriage bolt is round headed with a square neck. Then prevent the bolt from turning and tightening the nut. Commonly it is used for wood connections. Okay. The next type is lag bolt, that is lag screw. Here the large wood screw with the hex head. The screw is longer and it has the hex head that is used to wood or wood to masonry application. The next type is eye bolt. Has a circular loop. The head is like a loop, that is eye, that is instead of head. Used for lifting or anchoring with rope and chains. Next one is U bolt. That is shaped is like letter U with thread on both ends. Used to climb the clamp pipe or tubes to surface. Then next type is J bolt, that is shaped like a letter J, often set in concrete to serve as anchor bolt. Then next type is anchor bolt, that is embedded in concrete for structural connection. Comes in various shapes like L bolt, wedge anchor, sleeve anchors. The next type is flange bolt. Here the flange bolt has a built-in washer under the head. Under the head it has a washer. Then distributed load and provide more clamping force. It distributed the load. The washer is distributed the load and provide more clamping forces. The next type is shoulder bolt or stripper bolt. Has an unthreaded shoulder between thread and head, used in mechanical assemblies like pulley and linkages. Then next type is stud bolt. The thread on both side of the bolt has a thread or entire length. That is common in flange connection, especially in piping system. The next type is square headed bolt. Here the square headed instead of hexagonal shape, the head is like a square shape, that is used for aesthetic or antique style is fastening. The next one is T bolt. The T-shaped bolt that has fit into slot, common in machine tool, table and adjustable assemblies. These are the different types of bolt that is used for our structural designs. Then next about the part in structural steel section. What are the different part of structural members? That is, each steel section has the specific components that contribute to structural behavior. First one is flange. Here it is a flange, shows in case of I section or T section. The horizontal element, that is I and T section, is called as a flange. It resists the bending stresses. That is, flange member is resist the bending stresses. The next one is web. Web is a vertical element connecting the flange in I and H section. It resists the shear force. The next one is root radius or fillet. That is curved transaction between web and flange. Between the web and flange there is a curved portion, that is it is called as a root radius. It reduces the stress concentration. Okay. The next one is leg, that is in angle, that is arms of angle section, that is it may be equal or unequal. It provides stiffness and connectivity. Then about the thickness, it includes strength and stiffness of the any sections. Okay. Then next about depth, the total vertical height of the section, that is depth is called as the total vertical height of the section, that is directly related to the flexural capacity. Then about width, that is horizontal dimension of the flange or angle leg. Then about the hollow core, that is hollow core in case of circular, square or rectangular. Here the center is empty portion that reduce the weight. Because it is hollow section, therefore the center of the portion is hollow, empty, therefore it may reduce the weight, and aid to translational resistant and acidic. Then about the part in industrial steel structure. For industrial, different part is there, that is consists of multiple key structural components that is designed to handle specific load and function, that is based upon this condition. First one is column, the vertical member transferring load from beam to foundation. Then beam or girder, that is horizontal element that support load and distribute them to the column. Then gantry girder, it support the beam on crane in, this is the gantry girder, it support the beam for crane in industrial base. Then roof sheeting and cladding, this is the roof sheeting and cladding, the panel that provide weather protections and enclosures. Then this is about the base plate and anchor bolt. This is the base plate and this is the bolt that is connected the column to foundation. The next one is staircase and walkway, that is access path for operational and maintenance. Then about the business floor, that is intermediate floor that is used for storage or office space within the industrial shed. Then different type of trusses, that is triangular formwork that is used to support roof over the large spans. Okay, these are the different type of trusses that is used for the industrial structure. Then purlin, that is secondary member that is laid perpendicular to the truss or girder to the support of the roof sheet. Okay, this is the purlin, it is a laid perpendicular to the truss girder. Okay, then next one is bracing, that is diagonal members that provide the lateral stability. To reduce the lateral stability, they are providing the bracings, that is diagonal member. It is also different type, that is single diagonal bracing, K bracing, then cross bracing, etc. Okay. Then next about the type of structural analysis in steel structure. For this type of members, that is about the design of steel structure, we are analyzing, that is before design we need to analyze the structure. For this different type of analysis is there. That is analysis in structure determines the internal force, deformation and stability under various loading conditions. Okay, that is the main types that is include. First one is linear static analysis. Okay, in this linear static analysis, that is assuming material behavior is linear elastic, then suitable for all small deformation and simple loading. Okay, the next type is non-linear static analysis. On account of material non-linearity, that is example yielding, and geometric non-linearity, that is example large deformation, we are using non-linear static analysis. Then based on dynamic analysis, evaluate the structure under time varying loads. It includes free vibration, forced vibration and response of dynamic load like earthquake and wind. Then P delta analysis, it is one of the second order analysis that considered additional moment generated by axial force in a displaced structure. Then about the elastic analysis, assume the structure behave elastically and return to original shape after unloading. Okay. Then next step is plastic analysis. Here the plastic analysis allow the redistribution of moment beyond yield and providing insight into ultimate load carrying capacity. Then about next step is about stability analysis, or it is otherwise called as the buckling analysis. It determines the critical load that causes sudden deformation or collapse due to instability. The next step is model analysis, identifying the natural frequency and mode shape of the structure, that is it is useful in seismic and vibration studies. Okay, from this basic introductions about steel structure, I conclude my presentation. Thank you.